So this is an example. 20% of the item produced by machine. 20% of the items produced by a machine are found to be defective. So we are considering a defective. If a sample of 5 items, right, sample of 5 items from a production is selected at random, find the probability that out of 5, exactly 2 items are defective, right? So when we tell in our normal terms, there's a machine, it produces infinite number of items. So quality control staff pick 5 items here, randomly 5 items, and bring that items to the laboratory, and they are testing whether the items are defective or in good condition. And normally, on average, the machine produces defective items on average 20%. On average, 20% it may defective. Out of 100, 20 units may be defective. Now randomly he picked 5. Now the question is, what is the probability of getting exactly 2 items? Exactly 2 items. Here is it's a binomial distribution, since it has 2 outcomes. Either it is a defective item or non-defective items. Non-defective items. Here we consider a defective item as a success and non-defective items a failure. Failure. Here success rate P is 0.2 and failure, probability of failure Q equal 0.8. It's 80%. Now we know the formula to find out the probability binomial distribution. Probability of getting exactly 2 items defective. Here then we can write NCR, the formula, right? NCR P Q, here R, and here N minus R. Here we know that our sample, our total outcome is 5, N equal 5, and C combination R here exactly 2, and P is 0.2, R is 2, and Q is 0.8, and N is 5, and R is 2, therefore 3. So when we solve this, we can find the probability of getting exactly 2 defective items. So we can apply the calculator here. Is it visible, the scientific calculator? Visible to you all?
Yes, sir.
Okay, now let's see. There is a function called NCR. Here 5, right? 5, no? Right, here I press 5, and shift. Here C and 2. NCR into 0.2 power 2 into 0.8 power 5 minus 2 equal 3. Probability is 0.2048. So probability is 20.48. Clear? So the the probability that find the probability that exactly 2 items are defective. So exactly 2. Right? Here is here the result probability of getting defective item exactly 2 equal 0.2048. It's been 20.48 percentage. Now we move to second question. At least 4 defective items. At least 4 defective items mean probability. So altogether 5 items. No, we are in a sample. We are getting altogether 5 items. What are the possibilities? All 5 items, or 4 items, 3 items defective, 2 item, 1 item defective, 0 item defective. There are 6 possibilities. 1, 2, 3, 4, 5, 6. There are 6 possibilities. Now this one, the first part we discussed exactly 2. So that the probability is what? 0.2048. The second question, at least 4 defective items. At least 4. I mean, it can be 4 items or 5 items. At least minimum 4. Then, so we can take the probability of this, probability of getting 5 defective items, probability of getting 4 defective items. And if we add this together, we can find the answer. We can find the answer for this question. Here, what's the equation for getting exactly 4 defective items? Probability 4, and here probability 5, and we have to add together. So what's the equation here? NCR 5 C 4, and here 5 C 5 into P, that is 0.2, and R would be 4 into 0.8, that's Q, then 5 minus 4 equal 2. And here 0.2, here 5 into 0.8, and here 0. 5 minus 5 equals 0, and here it should be 1. No, it should be 1. 5 minus 4 equal 1. Right. Now let's see, let us calculate the value of these two probabilities. I use the calculator. If you want, I can display, and if you want, I can show you. So first we need what we need. Here 5C4, 5 C 4 into 0.2 power 4 into 0.8 power 1. Right? Then it is equal, sorry, it is equal 0.064. 0064. Right? Then we apply the second one. Here we can edit. We can edit here. It should be 5. It should be 5, and it should be 5, and it should be 0. Then we'll get 0.0032. 0.00032. So if we add these together, 0.0064 equal 0.00672. So it will be the answer, right? Let's see, check the answer. That answer could be this 0 point here, 0.00672. So we get exactly the same answer. And next question. 2 or more defective items. 2 or more defective items. Here, again I repeat, sample of 5. So there are 6 possibilities. 5, 4 defective, 3 defective, 2 defective, 1 defective, no defective. Right? So there's are possibilities. Here, question, 2 or more item defective. 2 or more. Here, 2 defective, or 3 are defective, 4 defective, 5 defective. So we have to get the sum of all these 4 probabilities. And we know that the sum of all probabilities equal to 1. But rather than calculating all these 4, it takes time. But if we find the probability of this, getting probability of 1 or getting probability of 0, then we deduct this value from 1 so that we can get probability of these values. So that we will start work on finding probability of getting exactly one defective item. So NCR 5 CR equal 1. Here 5 R equal 0, and 0.2, here 0.2, and 0.8, 0.8. Here R equal 1, here R equal 0, and 5 minus 1 equal 4, here 5 minus 0 equal 5. Then this is probability 0. Then if we add this together, we can find the probability of these two. Let us work on this. I start from 0. Here 5 C 1 multiply. So I add bracket, right? I will add bracket. It's easy. Into 0.2 power 1 into 0.8 power 4. Then I close the bracket plus NCR 5 R equals 0 into 0.2 power 0 into 0.8 into the power 5. Then close the bracket. Then we will get 0.7372. Then, so this is P0 and P1. No? Then we need actually 1 minus P0, P1. Then 1 minus this value equal what? Then we can directly calculate 1 minus answer. 1 minus answer equal 0.2627. Let's check the answer. You see, we get the same answer. We get the same answer, right? Now we move to the next part. If such 1,000 samples, so many of you are asking this about this. If if 1,000 such samples, each consisting of 5 items, are investigated, find the expected number of samples. Right? The question is not finding the probability, find the expected number of samples. Expected number of samples. Here, as I told you earlier, this machine produces certain number of items continuously. The machine produces any item. The previous example here, so they take one sample. They take one sample. Each sample consists of 5 items. So these 5 items will be tested, right? Tested, and we have found the probability of getting 5 defective, 4 defective, 3, 2, 1, 0, right? So this is how we found the possibilities and probabilities. Now the question is, right? The question is, sorry. Now they are, right? They are getting samples 1,000 times. They are getting this machine. The machine produce output. From that machine, they are getting samples 1,000 times. 1,000 times. And in each sample, they are testing 5. So we discussed this earlier here, this part. This is one sample. One sample. Remember, one sample consists of 5 items, randomly 5 items. Likewise, for laboratory, the quality control technician take 1,000 samples. 1,000 samples. Remember, each consists of 5. So therefore, altogether 5,000. So that's not the matter. Here, we want to find the exact number of samples out of this, right? Here, 1,000, no, 1,000. The investigator want to find exactly 2 items defective. Right? The laboratory technician needs to identify 2 defective items. To get 2 defective items, the quality control technicians, how many samples he should take out of this 1,000? Let's see. In one sample, the probability of getting exactly 2 items, 2 defective items, we already found. Is what? 0.2048. In one sample, the probability of getting defective item is what? 0.20. To get 2 defective items, how many samples you want to take? Here it's very straightforward. NP, we have discussed this one in the previous sessions. NP, expectation. N, here number of repetition, here number of repetition is 1,000 and the probability is 0.2048. So therefore, it's straightforward. Here, how much? Altogether, 20 times. 20. Yes, 205 times. 1,000. Here, yeah, 1,000 into 0.20. So he want to repeat the test almost 205 times, right? Out of 1,000 sample, he need to do 204 samples. He need 204 samples. So when we round it, we can say the laboratory technician should take at least 205 samples, then only he able to get 2 defective items. 2 defective items. To get exactly 2 defective items, he should get 205 samples. The second question, at least 4 defective items. At least 4. So it means in a sample 5 or 4. 4 item defective, 5 item defective. So to get exactly at least 4 defective items out of 1,000 trials test, simply we know that already we know the probability of getting at least 4 or 5 items is 0.00672 into 1,000 times 1,000 repetitions, and it's equal to 6.72. So he need at least 7 samples to get for at least 4 defective items. And here 2 or more defective items. What's the probability of 2 or more defective items? In one sample, probability of getting two or more defective item is 0.267. 0.267. In one sample, 0.2627 into thousands equal. So the technician should get 200, almost 263 samples. They expect to have 263 samples. Is it clear? Is the question clear?
Yes, sir.
Yes. Now we move to the next part, Poisson distribution.